Hello, fellow Mythrunians. Welcome to another live stream. We're going to be playing with clouds again today. Yeah, so without further ado, let's go ahead and get started. Those are the patrons scrolling up, helping me keep the lights on. Speaking of lights, let me turn my little accent light on up here. Oh, I will point out too that the YouTube channel is like 4 subscribers away from 1,000 subscribers, which would be kind of cool. I'm distracted here at the moment because I'm looking for like that town we test the clouds in. I'm trying to find where it came from because I would like to export the data around the town. Yeah, this is an old world. I'm not sure this is it. I don't do a very good job of documenting where things come from sometimes. And so, this is not the right way. So I was looking around for an area that was similar. Anyway, that's like advanced stuff. I wanted to be able to re-export the terrain from around the town so that I can use that as input to the cloud model. Unfortunately, I don't remember where I got that town. So I mean, I would need to figure out then how I exported it in the first place. So anyway, we'll mess with that another time. Oh, I suppose I could show what I've been working on with respect to the bandit camps. I'm still kind of no, that's not what I wanted to do. Poop. Well, I'm going to exit out then. Yeah. It didn't like that. I'm still messing with routes, basically, the roads and stuff, because it's like a target of opportunity sort of thing. Did I? Oh, this one. That's the one. Target of opportunity. So I was already looking at it to do like the sort of wide scale paths between. Oh, I didn't add my little thingamabob. Little pop-up dashboard. There we go. So let's minimize that again. Yeah, okay, four viewers this time right from me. That's cool. So I was playing with the road mappings between towns, or just like the general connections. And since I was already there, I'm like, well, how far can we get it to where we're actually plotting roads? And so I've been, well, for one thing, I needed to do rough plotting to even finish that bit. Excuse me, I'll show you what I mean. I think this will be quick, assuming I haven't broken something. Okay, yeah, so she's in the middle of nowhere right now because I was testing some things. This turns out to be interesting terrain in this particular world. Okay, so what do we want to do? We want to say map admin, and then we want to say bandit camps, even though it's not actually making bandit camps. But what it will do is it'll plot a bunch of routes. So it tries to connect all of these points of settlements. And so these dark blue lines are like where it did the Delaunay triangulation. There we go. To connect them, and then these other lines, like the green ones and the red ones and the white ones, are where it actually did like a rough plot using the 128 meter sampled terrain to figure out, what route would actually have to take between those two things. Yeah, so in like this case, this line went straight across the thing, but it figured out that it was actually quicker to go around this way. It has some problems because it actually will route through water, which it shouldn't do. But so that's what I've been playing with, and then debugging why this path is too long when the, like, why is the red path too long when the blue path was fine? And so checking and tweaking my algorithms. So when I get the road networks built, then I'll know, like, where roughly bandit camps should be. It's just kind of, it's one of the big missing features of the game, and while it's a sidetrack from what I'm doing, I do have to remind myself every now and then that all of this needs to get done eventually, and so it's not like wasted time, it's just delaying getting that one feature in everybody's hands. But on the other hand, I think if I could get actual roads in, that would really change the character of the game. So anyway, that's that. Let's get back to clouds. I've been messing with sort of trying to get it ready for the cellular automata. So messing with parameterization, and I added a bunch since last time. And I finally, right before the live stream, I added super run because I was getting annoyed at how long it took me to traverse this map. Yeah, so we've got the clouds. Okay, so I've got this grid that I need to be able to toggle on and off because it's really ugly. But the grid is showing where the actual cloud voxels are. I don't think we should have to go so high to get above the grid personally, but yeah, so these, it's like, you might not be able to see it actually because I don't set the line thickness. What is the parameter to set the line thickness? Let's bump that up. Let's see, render state, LMNOPQR, render state, there it is. So I think it's on here that we can set the line thickness. Set line width, there it is. So let me go where I defined this. So let's set it to 2, or not 0.2, 2, see what happens. The thing is, I think it's going to be too obnoxious for the grid itself. Yeah, so I don't know. Let me maybe make it less transparent too, so you can see. But the grid is really obnoxious unless you're really up close to it, so I turn it, yeah, see. But those are like the 128 meter size of a particular cloud voxel. So this on its own is kind of annoying to see all the time, and certainly at that alpha, it's really painful. Ruh-roh, where'd it go? There it is. And so like right now the clouds, normally like clouds are double the size of the voxel, and so if we take them down to 0.5, then they fit fully within, and you can kind of see, you know, each of those puffs is within one of these 128 meter squares. A real cloud puff in real life is like 1,000 meters. But this fits better with the terrain and allows the clouds to kind of interact. Where's the one that, yeah, so there's some of these that are closer to us than the mountains. Anyway, I was trying to figure out where this town was, and I think in the real game that this was the spawn mountain. But no matter. I mean, I'd have to, the other option is just to re-export a different town. I just have to figure out how I did it. So anyway, we might not get to play with terrain, but I wanted so if you imagine this 3D grid that we've got sitting here, oh, let's see how fast I can fly. Yeah, so here's a cloud that's sitting right in front of us. Let's turn up the alpha so you can see. So here's a voxel sitting right in front of us, and so it's fully inside this particular grid cell. And so eventually I need to get these so that they look correct from all angles. They do not. You know, only the clumps of clouds have any kind of real lighting. So I have to fix that. There's a whole bunch of things to fix, but I mean, I was getting pretty good looking visuals, so I'm kind of stoked to get this in the game at some point. So where was I going? Yeah, so I mean, I think that was the spawn mountain. I can't be sure, but what I wanted to be able to do was have the terrain interact with the, so if the cellular automata is this grid, so this cell affects the cells around it, and that may, cause different clouds to form and move and stuff like that, that the terrain would affect that too. And I like that idea because based on the cloud formations in the sky, you might be able to like guess some things about the terrain over there. Like if there's no clouds in this direction, you might guess that there's a desert over there. Or if there's like a big clumpy cloud here, you might guess that there's a big mountain over there because the clouds are kind of getting caught in a sense. That kind of thing where you could see a little bit over the horizon if you understood how weather patterns work and stuff. I like the idea. I don't know if it'll ever get there, but anyway. And so this is what the normal clouds would look like, and then back to 0.5. Oh, I actually can't do it that way. I have to 1, 2, 3. Yeah. So that's the way the clouds have been looking. Let me real quickly parameterize this grid because that's going to be annoying. Let me think. Where do we want it in the... let's make a debug panel real quick. If a cloud looks like a whale, there's an ocean below. No, not anything abstract like that, but clouds are affected by the terrain around them in real life. And so, and obviously my model would be simplified, but if you could look at the horizon and see that, over there to the west we commonly get this kind of cloud formation, then you might be able to guess what the terrain is probably like over there without ever having visited, farther than the current map can see. What was I doing? Oh yeah. Let me first of all, geometry, voxel grid, and I think, oh no, let's call it a spatial voxel grid view. Nah, can't spell. Let me try to get this done really quick. In fact, we'll make that not the default. And then what I want to do, dark clouds over dangerous dungeons. Yeah, exactly. Or, hey, that's not a cloud, that's smoke. Maybe there's a volcano over there, that kind of thing. Yeah, so I think we want to say toggle grid. We'll make a new panel. Panel equals container add child. Oh wait, no. We want panel. We want to just duplicate this actually. No, we want to duplicate. Oh, I changed the roll up. We probably don't need to keep track of the roll up at all, since I'm resetting it. So no, this roll up. This is like we did this all hastily last time. So panel equals new container, debug, and so then panel add, add child new action button cloud grid. I'm just gonna call method action toggle grid. This toggle grid protected void toggle grid. Let's see if this even compiles, because like did I save it? Hey, how's it going, man? Uh-oh, nope, I didn't do it correctly. Could not find matching constructor action button. Yeah. And let me just look it up rather than waste our time. Call method action. How's everybody's week gone? Yeah, this will work. Gotta change the name of that though. Alright, let's go back into the game. Yeah, it does. Yeah, it does. I always want to get more done than I get done. Okay, so there's no... that is a good question. It is not the latest. I don't think it says in here, right? It's just pulling it from... users Paul into repository com jme3 oops org jmonkey engine oops I typed git. I need to I'm running some version of 3.6 but it's customized. Yeah. Oh, come on, guys. Just because the guy who wrote this editor is not making changes and hasn't for like 10 years, that doesn't mean it's old. It serves me well. Yeah, the problem is like I've heavily customized my JMonkey engine, and I'm not sure all of the bugs I've fixed locally have been fixed in the main one. And I've added some instrumentation to mine to, like, my my app state manager times all of the app states, and it keeps track of all of the times for the app states, and if a frame takes longer than a certain amount, it'll dump a warning log along with like how much time every app state took, so I can like debug slow app states. Yeah, so we've got the button now. Okay, cool. This is just like a cheap way of doing if voxel grid view get parent equals null, then attach the child, otherwise yeah. So now I should be able to turn that grid on and off if I want to. Like, yeah, there we go. Alright, so we're going to add another panel anyway. We're about to for the cellular automata. Yeah, I can go fast now. But yeah, we can turn this off and then see what the... Yeah, see, I'm pretty sure, based on memory, that this... I don't remember exactly which world this was. And unfortunately, I didn't put it in the name of the file. Yeah, what version is JME on now? It's right 3.10 or something? Or they're about to put 3.10 out? Anyway, I'm pretty sure just based on the view. Find out your thoughts on the recent AI PR being merged to JMonkey engine. I don't know that I noticed, to be honest. Yeah. I don't know. I didn't look at it, but it is a little weird. It's like at my day job they use Claude for a lot of stuff. Yeah, but I'm a fan of that because like one of the reasons I'm still on LWJGL2 is because of GLFW. Like it just not very compatible with the way Monkey Engine used to work. I think the key events work in a way that doesn't make any sense. I think that GLFW was broken on Macs. I think there was a lot of problems with GLFW that limited adoption. Certainly for me, that's why I never upgraded to LGBT. Yeah, that 3. I never upgraded that, so I'm still running on LWJGL2. Yeah, so that's okay. I think that's probably best, actually. I think that AI would do a better job at that than a human. But I think it probably deserves a lot of review. People at my day job use Claude Code a lot. Yeah. Oh, thanks, Ron. Nice to see you. Yeah, we've got the turtle-shaped cloud here and the face, but we're about to get rid of those actually because these are like just a fractal. These are just fractals. So I think actually I want to turn back on. I want to make the town toggleable. In fact, let's just call this visualization. I use the hell out of AI in my... Yeah, it has its purpose for sure. Like I said, like my day job, I haven't set it up yet because at the company I work for, if we want to use Claude, we have to go through all this training first, and there's a process to get accounts and all this other stuff, and I never have like 45 minutes free to sit and do one thing for 45 minutes during the day. And so I've been dragging my feet, but other people are using it, but I've gotten good at spotting the bugs in code reviews. All right, so we've got this. I want to add one for toggle town and toggle voxel. Toggle voxel cubes. Okay, so we'll put some things in here. Protected void. Toggle town. Protected void. Toggle voxel cubes. All right. So this should change our... it is funny. Like at least 3 times now, somebody at work will give me pushback on a comment on their PR or something, and then or they'll have made a Claude-related comment on one of my PRs, and I'll have a discussion with them in Slack or whatever, and then they'll come back and, and they'll say, Claude says Paul is right. And I always think that's funny. Like if you can get the AI to admit you're right, I think that's cool. On Google Gemini, I always think it's funny. Eventually, you can get a conversation to the point where it starts trying to get out of the conversation. Little does it realize I'm enough on the autism spectrum that I don't take those social cues. So if it's trying to like, oh, well, good luck with your game or good luck with what you're working on. A lot of times, Gemini, will include a couple options if you want to continue the conversation, like those old RPG games, where you could like click on the word and keep the conversation going. But then eventually you can get it to the point where it's just like, all right, have a good time. Good luck with your Good luck with your project. And I just keep asking it stuff. Okay, so that was good. I didn't save it. So let's see if it... Oh, no, it did. Okay. Alright, so we got those new buttons in. Let's... So if show town... So... I think I'll just cheat. Stay static, spatial town. And then, so if we have a town, we'll set it on here. And so then, if we have a town, if we don't have a town, we can't toggle it. Town equals null, return. In fact, I think we can put that here too. Like if we haven't loaded the town, we can't toggle. Thought Gemini was just being polite. Yeah. It's just usually Gemini is so like overly obsequious and gives you all kinds of options to continue the conversation. Would you like to talk about this part of it next or this part of it next? But kind of eventually you can get it. Like I frequently get it to the point where it's just like, all right, good luck. Like it thinks it's run to ground all of the things I wanted to talk about. But it is not correct. So if town equals null, if town dot get parent equals null. Oh, that's right. Okay, so if we did that, we already added the model, which is adding it to model app root node. Okay, I see. All right. Attach child town. I have to ask Jim to stop stoking my ego as me follows, rather than guess what I was trying to do. The number of mistakes that I would make if I was... Yeah, that's true. Yeah, I mean, it would just wreck the point system. But yeah, I do find Gemini to be a little too obsequious. But on the other hand, like Claude, the way they have it configured at work is really brutal. I like more somewhere in the middle. See, there's like Google has their AI workbench or something. That tends to be a nice middle ground because it's like more down to business. But yeah, it's always funny when I'm in the middle of a conversation and I remind Gemini who I am. Oh, you're Paul Speed. You created all this stuff for JMonkey. And she's like, oh, you're awesome. It's like, no. That was years ago, my dude. All right, let's see if we can toggle the town. Yeah, it's something like that. AI workbench, something like that. I was using it. I'm slowly going through the Moss libraries and I'm stripping them down to just the code and the comments. Just stripping out white space and stuff so that I can upload them into there and have it analyze them and then give me a sort of a summary. Such that it like lists like not only all the things wrong but sort of an architecture summary so that I can use that as like the framework to analyze other modules that might depend on those modules and build a big giant design doc that AI can yeah, they do, because there's also Notebook LM, which they've changed the name of, which I was messing with for a while too. That one is way too down to business for me actually. I put it in like a bunch of different modes and it answers every question in all the modes. It's kind of annoying. Alright, so we have a toggle now. We should be able to toggle the town on and off. It's like, whoop, whoop, whoop. Oh no, it's not working. Is that because maybe this needs to go at the end? No, okay, so this is not setting the thing. So let's say, let's put this back where it was, and we'll have town scene equals null. Town scene equals scene. And then, yeah. I should really organize this better than I have. Oops, and before I forget, let's take this down here. And then if towns, oh, I did it backwards, that's why. Alright, so it was probably working fine before. Alright. Notebook LMs, infographics are fun to generate. Yeah. I was trying to use it to work on some Mythruna design stuff, and I had uploaded a design document that included a bunch of lore and the background stuff there, as well as the game architecture in the sense of, you know, different world generation sizes, you know, tile sizes, chunk sizes, etc. And then I had put a prompt in to try to get it to help me both like design lore related things and architecture related things, and you know where those two cross paths. But I didn't get the default prompt or something set up right, because every question I asked it, it always tried to answer it in all of the modes. So first as a game architect, and then as a you know, lore designer or whatever. Like, some questions didn't fit, and like even when I would tell it specifically answer is this. The problem is like Notebook LM will default to only the information you've provided it before going out. It tends to only reluctantly, you know, bring in the information from the web, and I kind of wanted the reverse. So anyway, I now carefully partition my lore related discussions from my architecture related discussions, and then I end up having to cross pollinate information. Man, it is hot in here. Where did my little island? I must have turned that off. Anyway, so now we've got just clouds. Let me see if I can get the voxel cubes. What did I call that here? Show cloud blocks. Yeah, that's what I should have called it there. Yeah, that's fine. Okay, so show cloud blocks. So this is in here, but instead we can go if clouds dot blocks equals null, or clouds dot blocks dot parent equals null, then do the thing. Oh, add model's not going to work. I think we probably want our own route. So add model is nice because it automatically cleans up the models when I reset the script. And models, oops. I think, yeah, I see, it clears them up. Models is, it could have been a set. That would be better, to be honest. In which case, then I can just... Okay, so if cloud box equals null, let me see what redraw blocks does. It makes a whole new brand new one, doesn't it? Nope, it reuses. Cool. That's cool. So blocks always exists. I don't need to do that part. So if we're toggling it on, let's redraw the things. Oh yeah, I'm not going to be able to add it. What to do? What I can do is get application root attach child else cloud.blocks remove from parent, and then I should just be able to put this in the cleanup. That should be able to keep it from... Alright, let's see. Oh. Toggle town. Uh-oh. Row. App for cloud parameter state. Yep, that'd be true. Add model town scene. Oh, guys. I'm sorry we're getting so bogged down in just setup here. Just going to be important for us visualizing what's going on to be able to toggle things on and off. So yeah, I can't do this. I have to say get application. And I have to spell it correctly. And the same here, I need to spell that correctly. Okay, let's try this. Okay, it should at least load the town. Okay, cool, it did. Alright, there's the town. Now we should be able to toggle the town on and off. Blink, blink, blink. Yep. And we should be able to toggle the voxel cubes. Hey, look at that. And I've screwed up because... No, it's fine. I was going to say I didn't rename the thing on cleanup, but it doesn't need to know the app for that. Okay, so we've got the voxel things. We turn off the town, and so this is the direct. Woo! I forgot. I now have the super run. Yeah, so this is just the fractal generation of our clouds. Yeah, still some sorting problems, but you know, whatever. And so now, if we add the parameterization for being able to generate with cellular automata. First, I think before we start adding things, I may just do a like a dumb kind of flame version. For those of you who don't know, there's a cellular automata which is kind of looks like flames. Is this loaded? Yeah. So if you imagine this grid, and you have a cell here that's full, and then in the next pass, for anything with a cell below it, you partially fill it and erase the other one. So then you erase the other one, and then the next pass you'll get like another one, and so you get, it looks like something big and then just flows up and gets smaller, and so then you randomly like populate this bottom row with full X's, and then it kind of looks like flames going up. It's nice because step by step it's easy to see what's going on. It gets the automata infrastructure in for searching over the grid. So I think that's maybe what I'll start with, is just seeding some values around here and then watching them kind of flow up until they disappear. Unfortunately, these blocks we don't get to see partial values, and in fact the cellular automata that I'm modeling after, which is from this SIGGRAPH paper, they're using just bits, binary values, whereas I would really like these to be, I need to see it work a few times first, but I would like these to be fuzzier, not just off and on. But it makes some interesting clouds. Anyway, so let's start messing with that. And so we're going to want the ability to step the simulation. Probably we don't want to do it automatically at first. And I have packaged everything into this. Let's go ahead and start a class cellular automata. I'm not going to get tired of typing that at all. Automata parms equals new. All right, so we've got that. I could just call it CA parms, and then I don't have to type it all the time. All right, so we've got that. Yeah, so as we need parameters, we can put parameters in. And then we've got a cloud volume where we initialize all the things and we draw blocks. Yep, that's fair. Refresh cloud from fractal. Yeah, well, so we'll want one of these for refresh cloud from cellular automata. CA parms. Okay, so this one will go through the grid. Alright, so let's do the stupid thing for now. Actually, I just want to see. Nah, we'll just leave it on and off for now. So what we want to do is x equals 0, x is less than, I think it's xc size, x plus plus. For now, we're just going to fill in the bottom to make sure that it's working like we think. And so we'll set this. Oh, I see. In fact, let's keep doing this. Let's use I and j. K. K. So ijk. So I0. Okay, so we'll fill that in, and then yeah, we'll do that. Okay, let's see if that compiles okay. Yep. And brought back all of the settings we had before. That's good. All right, so let's see where we call update. Oh, yeah. And if it's enabled. So let's look up. Yeah, in fact, this will be good. So by default, it's going to be disabled. Public void set enabled. Boolean enabled. If this enabled equals enabled, return this enabled equals enabled. Boolean is enabled. Return enabled, and then version ++, and we will do the same thing. Actually, we want to steal some of this. Let's steal a whole bunch of this for this new one we created, and this needs to be a version to object. Let's use that. We don't need this stuff yet. And because I like to have a constructor even if it's empty, version, okay. Oops, crap. I accidentally hit Control V. There we go. Control C instead of Control V. Alright, set enabled, blah, blah, blah. Okay, cool. And so where we have this, we're going to want to have the cellular automata version, which I will do like this. CA parms ref. And then we're going to want similarly to do this, CA parms. Okay, and then this dot CA parms equals CA parms. And then what do we do in here? Oops. Crap. Alright. Right. Yes, so we want to do similar thing here for CA parms, and a similar thing here, oops, for CA parms. Clouds refresh, from, oops, CA parms. But the name of this method is not that. It's, yeah. Boink. Alright, so we're set up if we add a Boolean to toggle these things. Like here, so we'll have a fractal generation, we'll enable it, and so we'll change generation. So it's a fractal generation, and we will say add Boolean property I think I can just do enabled. I might have it backwards. I certainly have it backwards. Oh, nope, I just forgot to add the CA parms down here. Yep, that's what I thought. Okay. I had it backwards. I think add boolean property has to be the word enabled first. Yeah, I should have just gone with what I knew worked. I'm 99% sure it supports Boolean. Apparently. Work. 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 Okay, so that's working. And then we need to actually use it, which would mean where we come in. That's not what I want. Too many things going on at a time. Yeah. And then I'll say if CA parms is enabled. If not, CA parms is enabled. Return. And then down here, we'll say if not, parms enabled. Return. And then where we're doing. Oh yeah, maybe I'll just change to parms here because it's already localized. And then because we're basically these have like a mutual exclusion state, and so we'll make sure to refresh both of them. No, I think this is okay. Okay, now we're ready to start cooking with gas. Let's make another settings panel, and this one is for CA generation. How big is my? I could probably fit the full cellular automata. Let's see if that fits. Yeah, I actually have it backwards. Yeah, that's not the right enabled. CA parms. Okay. Alright, so if we show the cubes and we enable one of these. Yeah, okay, so cool. Let's turn off the town. Oh, it's about to storm here. Whee! Alright, so now we've got a basis to do some things. And so now we'll need a step. Crap. Alright, we're going to do this the slow and dumb way. No, I can't do it the slow and dumb way. So the problem here is that we want to reuse the previous values each time. So let's say we want a step. And we'll make sure that it's dumb, but we'll have to look in the UI each time. So let's first of all, if math.random is less than 0.5, seed the thing. Okay, so it's going to reset back to town visible. Turn the town off, toggle the box of cubes, and enable them. Okay, so now we've got, probably we want less than that. Maybe even less than that. Alright, so then when we do a step, we want to do that, but first we want to, for int j equals 1, j is less than j size, j plus plus, and we need to go. That's the thing, is like a lot of times for cellular automata you need like a copy. You can't, if we go from the top down, then we don't, for this particular flame thing, for the we should be able to get away with just going from the top down, looking below, and moving that one up. Otherwise you end up wiping out all of your memory as you go. But this is not going to work. We're going to actually need two different arrays, one for our work, and then we swap that to the real one so that we can use the existing state. Because in cellular automata, like in this case, in the first frame we put an X here. In the second frame, we're going to clear all the, we're going to clear the bottom layer, but only after, do we have to draw one, like say this is frame 2, we know we need to draw one up here, but what if there was already one there? We can't wipe it out because we needed to be able to draw another one up here, and so on and so forth. So you kind of need two separate arrays, one that is the original state from the last frame, and the one that's the working state for the next frame. And there's a way to kind of optimize that, but where you don't have to recreate the whole frame necessarily, or the whole array, but in general it's just easier. But I'm just by using my algorithm, by using this particular simple algorithm backwards, we can avoid having to do it. Val equals cells.getCell I comma j minus 1 comma j k, and then cells.setCell I comma j comma k comma val, and then we don't need to initialize the mesh again, do we? Oh, I see. Yeah, because every time we're regenerating the voxels. Yeah, okay. So we do every step, we want to do this, which is expensive. In the real version, probably not. And then I want to add a step button. And so we'll add props, our panel, add child, new action button, new call method, action, this step. Alright. Protected void step. And then cloud step. CA parms, I think. Yep. Alright, let's see if that works. Then we'll have our, well, only like halfway through the live stream and we'll have had our infrastructure set up to actually do work. Alright, so we want to turn the town off, turn the voxel cubes on, enable them. Alright, and then we should be able to say step. Whoops. No such property J size. That is the beauty of doing this live. Alright. Try again. To be honest, I should probably set the town and stuff to be off by default, but so that I don't have to do this every time. Yep, yep. Alright. Whee! Alright, now we should say step, step, oh no. Well, first of all, we want to set the cells to 0. How is this not working? We never actually get down to the bottom. That's why. Alright, let's try it again. Turn the town, step. Okay, step. Step, step, step. Yeah, so see, now it's working. Yeah, it's getting that crazy. Look at all that overcast. Look how overcast it is. So let's make... I don't know if you guys can really see what's going on. So, let me make fewer flames. How can I make it... The thing is, if we could have things flame out. Anyway, let's just try this and see. I basically made it less common. Yeah, so there's fewer of them, but you should see like each one of these will spawn a block above it. Ah, crap. What is it called? Oh, it's mask utils. I don't even know what mesh utils is, to be honest. Alright, come on, come on, come on, come on, come on. Enough putzing around with alright. Toggle box cubes enable. Up. Alright. So each step should make a cloud appear above one that was already there, and basically each of these will just move up and it'll regenerate a new layer. Except for it's not really clearing appropriately because each layer is getting way too many. Like, the bottom layer started out really sparse. So I'm still doing something wrong here. And in the interest of making sure that it's not a systemic issue, let me just reset here. So yes, that's right. Let's see what happens if we don't do this. So we'll just seed an initial layer and we'll let it rise. So then that should go up. Okay, so it's not clearing the previous layer. And we actually did have some clumps. So we need to at least which, to be honest, should have been what this was doing. So that should have been doing it. Yeah, this is going to drive me nuts. Step, step, step. Yeah, so that is working. Let's make the... Oh, the problem... So I only changed the threshold there and not here. So it was immediately filling in with a much higher value. In fact, we'll lower it down to even half that. Yeah, so it's kind of working. So you'll see, like, this particular voxel will move up as we do step, 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 step. Yeah, so this is basically a flame fractal, except for that we only have binary state. Cloud on, cloud off. Look at that! Alright, so now we can play with real cellular automata. How does the algorithm work again? We need some parameters. We need a parameter like the one we just had, which is sort of the random activation. Actually, I have notes that I cribbed from Google. So we could use these. They didn't really label what they do. Let's see, there's a full version. So that's including ground stuff. So humidity rise, vapor rate, or evaporation rate. What is G? Oh, generation, vapor generation, evaporation rate. What is E? No, that is the evaporation rate. What's the one I'm missing? The C, PC. Leeward neighbors have a much lower chance to spread activation against the wind. Okay, so this is a wind related. Oh, so let me look back at the previous version where the code was simpler. Yeah. Alright, the other thing we're going to need to do is switch to double buffering for the... where's my thing? Clouds. Alright. So not too bad. We're getting into the real meat of things halfway through the live stream. That's not too bad. Alright. So cloud volume, we're going to need cells working and cells. Alright. So cells will always be the one we render. But when we're doing this, and I ought to be able to go back to 1 less than j size, j plus plus. So if from the original cells, then cells working, we set cell, and cells working, we set cell, and then in here, cells, so cell array temp equals cells, cells equals cells working, cells working equals temp, and then cells working, we can clear it up here. And so what that means is I no longer have to clear this, I think. Alright, so let me just verify that my double buffering is working like it's supposed to. It's gonna kill me. Okay, so step, nope. That's gonna kill me. J size instead of Y size. That's what I should get for using I, J, and K instead of X, Y, Z. Alright, at least this doesn't take as long to boot as the whole dang game does. Enabled. Whoops. Whoa. Alright. So there is a slow. Okay. I set the super run speed really fast, like 150 meters per second or something. Okay, so let's see. So if we watch a particular, so a particular voxel, this particular voxel, we should be able to keep watching it move up. Yeah, move up, up, up. That's it right here. Although somehow we end up with stuff above it too. How'd that happen? Something is screwy. I'm going to set the threshold much smaller so that we can see what's going on a little better. I think there's some kind of bleed. Dial down. So step. Or maybe I'm just seeing things come through on a different level. Yeah, that's what it is. Step. Yeah. Yeah, I think it's working okay. Yeah, I just really wish we had. I wish I picked a block that, like water or something, that allowed me to have multiple levels. Okay, so the double buffering is working, which means we don't need to. Oops, we don't need to clear every time. And so now, let's just take this and keep it aside for a second. Call it flame step. And now we can do other things. What we want to do is, now we want to understand what we're making, which is basically this. We've got 3 rules we're trying to implement for each. Pepsi's gone. Alright. So let's make a comment up here. Put this stuff in. Okay, a cloud forms if a cloud already existed and didn't evaporate, or if humidity was present and triggered by an activation state. So the logic looks like this. If cloud and not evaporate, or humid and okay. It gobbles the it munges the code together. Okay, so that's that. Rule 2. It spreads if a cell is currently inactive but has vapor and catches fire from a neighboring cell. Okay, so I think actually this is just explaining what it's about to do. Yeah, that's what it is. Okay, I get its formatting now. And so yeah, we got to check around all the different ways. And then tiny chance of spontaneous activation, which is fine. All right. So we're going to need to look around in all the directions. What is, so check 6-way neighbors for act. I think we're okay to just use the parameter, the one that has a default value. So let's boolean is neighbor activated. Cell array cells. Nope, we don't want to do that. Source int x, int y, int z. And so we'll want to look in all the directions. Okay, so for every one, we're going to want an evaporation parameter. We're going to want a spontaneous parameter and generation parameter. Oh, I see. We're keeping alright, I am going to use some of the extra bits for these. Each cell, it needs to have 3 values. If we look at this, is it activated, is it humid, is it a cloud? And currently we only know, is it a cloud? So I'm going to use we have lots of bits. We have a full integer, and we're only using the standard, block library bits, which for masks. So we have the type, which is just these. We could use the subtype mask. Yeah, probably we want to use the so here's the layout, right? Yeah. Type. I used GG for something. Was GG? Don't we store lighting in here too? Oh no, light's its own array now. That's right. Alright, so we'll just use the subtype. Get full type. Yeah, okay. So get subtype. And we'll get the bits from there. So what do I want to say about that? Protected Boolean is active. Is act. Just call it that. Int val. Protected Boolean. Actually, just call it private final, so that Java will optimize it for us. Is hum int val private final boolean is cld int val. Alright, so this one is mask utils get type val equals 1. So that's that. This one is int sub equals mask utils get subtype val if return sub and 0x1 not equal to 0. So if bit 1, just flip these around. So if it's act, it's bit 1. If it's hum, it's bit 2. And is cloud is the type itself. Okay. And so for each cell, yeah, you can go full on. So get the value ijk, and if so we'll need some parameters. We're going to need evaporation spontaneous, and for now we'll just use that. CA parameters, and we won't make them, we won't expose them through the UI yet. Private double evaporation, private double spontaneous. And what does it say good initial values are? I think that was also in my I don't know, we'll just use 0.25 for both of them. Let's see, it looks like maybe 0.25 here. I don't know how this relates to what it just set up there, because PC isn't even represented up here. Right, it's not Yeah, so we could add, that's the spontaneous. We do want that. Otherwise, nothing will ever get... I think nothing would ever get generated. That's the part I missed in my cut and paste. Alright, let's look back over here. Yeah, there we go. Alright. So, well, first of all, if we're just going to hard code them, I don't need to put them up here. We only need to dump them up there when we have actual, when we want to put them in the UI. Right now, I think let's just get something sort of working. Okay, so evaporation, we'll just call it 0.2. Spontaneous 0.2. Okay, so Boolean is cloud. Oops. Cloud equals val. Okay. Boolean evap equals math.random less than evaporation rate. Let's change this to evaporation rate. I don't think that's right, but... And so... Boolean next cloud equals cloud and not evap or hum and act. So we're going to need to know. Oh, what I call it? Yeah, is hum. Okay, I did. Act equals is act. Now, okay, so next cloud equals that. Rule 2. Activation represents the thermodynamic energy moving through the atmosphere. If it spreads, if a cell is currently inactive but has vapor, and catches fire from a neighbor. So logic is next. Neighbor active. Yeah. So this is where we have to check the neighbors. This is the one I haven't implemented yet. Is neighbor activated? And this is cells. I, comma J, comma K. Is neighbor activated? Is neighbor activated? Neighbor active, that's what it is. Okay, that's fine. Let's change the name. Let's just set false for now. Is neighbor active? This is not going to be very interesting. Next activation, Boolean next act equals not act and hum and neighbor active. And neighbor active, right? Yep. If not, okay, we could add spontaneous, but we won't. And so then, if not, next, what is next hum? Next hum is not set. Next hum equals hum. that doesn't look right. I might have to look in the paper. So next time equals hum and not act. I see. We're missing a line. Stupid reformatting. All right. All right. So then, boink, 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 boink. And if not next hum, then next hum equals math.random is less than precipitation. Double precipitation equals 0.5. All right. Okay, so then from these, we want to say sub equals what did I set? I said next hum is 2, so sub equals 0 if next act sub equals sub, or if next hum, yeah, I'm going to change this. Skip. Alright, next hum sub equals sub or OX2, and then new val equals what's the mask utils to set all of the values at once? Get set type. Is there a set subtype? There is. Okay, set subtype. I can't set them all at once. Int new type equals cloud, then 1, otherwise 0. New val equals mask utils set subtype, which is which? It is value and then the subtype. New type sub. And so then cells working set cell ijk new val. We don't need this. Alright, let's see what we blew up. I don't think this is going to do anything at all close to what we really want. But I had hoped it would at least not crash. Mask utils get subtype. What is it then? Get subtype. Subtype versus subtype. Oh boy. There we go. Here we go, here we go, here we go. There I go, there I go, there I go. Alright. Probably we don't want to be seeding the thing anymore, but it is convenient to be able to find our voxel grid space again. Okay. Alright, let's try stepping and see if it blows up this time. Yep. No such property, precipitation. And this one's not spelled right either. Let's just call it precip. And then I don't have to type it correctly. Alright. I'm gonna step once right away this time rather than like zooming out and stuff, because if it's a compile error we'll find out right away. Okay, clouds, toggle town, I don't know about step. Yep, okay, so it's gonna blow up again. What's it blowing up on this time? Next act. Next act. Alright, let's try again. Come on. Come on. Alright, no, we don't want that, we don't want that, we don't want that. Step. Hey, it didn't blow up. It didn't do anything, but it also didn't blow up. Okay, so step, 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 step. First of all, let's make sure that it's even right. I would have expected it to do something. If cloud. Oh, is next cloud. So all these should be based on next act, next cloud. Okay. Ba-da-ba-da-ba-bum. Step. Hey! So these should evaporate over time and not come back, because there's nothing to activate them again. Okay, so it's doing something right. It's not doing the right thing. I almost want to debug can we I'm trying to think of how best to debug this. I kind of want to change the block types based on what all of these flags are. So so if val is cloud, so let's just say and 1. Oops. It's not equal to 0. So that lets us put other data in that. And so then let's just temporarily say new val equals new type. We'll move that over 1 bit. And then we'll OR it with oh wait, new type. That's what we want. New type equals new, or equals sub 1. So basically we're basically taking this subtype that we're also encoding it somewhere else, which is what we use to check these, but we're also using it to change the block type. I have no idea what these block types will be, but at least we'll be able to see if these humidity and activation things are actually being set. Okay, so let's say step. Oh boy. Yeah, so they're definitely getting set. I think it's probably just because we're never checking the neighbors. Yeah, because these are... Wow, it's getting saturated. Holy moly. I wonder if that's just because the clouds are never forming. Are we not clearing? We're clearing. All right. I don't know what any of these values mean, though. Like, I don't remember what index grass block is, for example. Oh boy. Is this even... Okay, we've got lots of blank spaces in here, but they all seem to be grass blocks. I think grass blocks are... It's supposed to be... I think sand, dirt, grass, 2, 3, 4. So this would be 4. Yeah, and then this stone block down here is 5. I think that's the way. Like, original Mythruna had, you know, just a very few block types. And so as I've reconstructed each new set of block types, just for convenience, I've left those initial indexes the same so that, you know, well, for 1 is the bad block, which moved everything, and I think there used to be a different 1 block. But then 2 is sand, 3 is dirt, 4 is grass, and then 5 is stone, which means this is a combination of bit 4 and bit 1. So this is a set block, but it's also got that bit 4, which would be or bit, yeah, what would be the 4? So it's the third bit. So this bit moved over 1. So it's the humidity. So humidity is definitely precipitation's too high. Let's set precipitation to be something small and see if this changes. Alright, so enable toggle town, toggle voxel cubes. Alright, so let's go back to looking at this. Woo! We got a storm brewing outside. Woo! Alright, step. Alright, so see, yeah, we get less humidity this time. But it's never evaporating. And never making clouds. Well, that's because we're not looking at the neighbors, I think. What makes a cloud, what makes new cloud happen? New cloud only happens if we're a cloud and we're not evaporating. So if we were already a cloud, we're going to stay a cloud for a while. Unless we randomly evaporate, which I have set really low. Okay. Or it's humid and active. So activation is not actually getting set. And activation only comes from we're not active and we're humid and a neighbor active. So with neighbors never active, we will never set ourselves active. And so we will never activate a thing. Okay, so let's take this out for now. Oh, that was a useful visualization, and we have to implement the neighbor stuff. Radius equals 1. Nah, we'll just do it. For int x equals -1, I is less than or equal to 1. Oh, x. X plus plus. Thing is, we only want the 6 directions, I think. So we'll do this a little differently. If boy, is act source get cell x -1 y z comma 0 return true. So we'll just unroll the loop. So we're going to do all 6 directions in. So this one's going to be... That was east-west. Now we'll do north-south. And now we'll do up-down. Alright, so that should change this a little bit. Okay. Boink, boink. Alright, step, step, step. Nope. Okay, let's go back to our weird visualization. So we can see what the different activations are doing. Step. Okay, so we've got some that are still not humid, but we're never setting any of the other values, basically. So humid gets set. Randomly, or if we're activated, right? Or if we're not activated. If we were humid and we're not activated, we're still humid. I kind of just hoped this would work. Let's step again. Is it just forever getting humid? Yes. Okay, so let's say if next act new type equals new type or 0x2. Let's debug one parameter at a time. Okay, so nothing is ever getting activated. We can confirm this by changing this to hum, because we know hum eventually saturates, which is probably a problem. So this one should all end up in grass eventually. Right. Yeah, sand is now the new because it's voxel type 2, and so eventually sand gets full. So humidity just keeps going up. Activation, we never activate anything. Is neighbor ever active? Well, we never activated anything, so neighbor would never be active. So next act, if we weren't act and were humid and a neighbor was active. That seems a little too restrictive. Cloud forms if a cloud already existed and didn't evaporate, or if humidity was present and triggered by an activation state. So if we're not evaporating or we're humid and activated, activation spreading. How does the initial activation... Yeah, so you gotta have spontaneous activation or nothing ever gets activated. Like, how would you ever... Like, the logic is such that next act is never going to be true because neighbors were never active. Because there was never an active. You had to have seeded something as active. So I think we're going to have to add this spontaneous or right next to the next act. I think that's the same as doing this. Right. If math.random's less than spontaneous, next act equals true. I think that's the same as putting an or after all this. Wait. Or is it that we want... Maybe it's not supposed to be all in parentheses. Maybe it's supposed to be if all this things is true and neighbor active. What is the operational order of operand Java operand ordering between and or? The AND operator takes precedence over the OR condition or operator, but operands are always evaluated strictly from left to right. So let's ask it. It's my problem is like my logic brain goes out the window when I'm talking to you guys and trying to code on a live stream. So so let's paste the code. Whoa, hello. Let's paste this in. And say, please put parentheses to show ordering for this. Yeah, okay, so it is an OR of the whole thing, right? Yep, and then and cleaner alternative. Yep, that's what I would have done too, just to make it clearer for the next guy. But that's cool. So now I understand that this is an overriding precipitation, and how I have it here is fine. Right. So this would have been the same thing as putting all of that. What did we miss? Wait. Not act and hum and neighbor active. Oh yeah, this one. Yeah. This is the one we're doing. Yeah, so it's basically all of this. If it's not that, then we can do this. Let's see if that changes things. Do we get cloud-like stuff? Of course, we're still got the little debug thing in, don't we? Yep, that's fine. I wanted to see it anyway. Toggle town, blah, 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 enabled. Step. Wait, are we still looking at humid, or we're looking at... Yeah, we're looking at humid. Let's look at act. Should get some activation. Step. Oh yeah, we got lots of activation now. Do we get any clouds though? Okay, so we get lots of activation. Right, next act. Yep. Step. Aha! We're getting clouds. Yep. Maybe too many clouds. Alright, so let's turn this off and see what our stuff is doing, and we may have parameters to tweak. Alright. Target town. Voxel cubes. Enabled. Step. 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 Yeah, so basically evaporation is set way too low. Let's evaporate faster. I think this makes a dry climate. Toggle town, toggle voxel cubes, enabled. Step, 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 nope. I mean, it's a pretty saturated sky. It's not bad looking. It's just like way overcast. But precipitation's really low, so we shouldn't be... Perhaps... what else? Set spontaneous really low. Let's change evaporation rate even higher. We haven't really incorporated wind or anything in either. What does it look like if we turn back on the grid over here? Yeah. What if we make our clouds really small so we can see them? Pump up the volume there. Yep, so see, those are all those voxels are the same as all these voxels. It just seems like too many clouds. And I think, like, if we take the spontaneous part out, we'll never get anything. Yeah, I don't see how we would ever activate anything. Let me make spontaneous really low. What is precipitation used for? Precip is used for humidity. So the next thing would be to plug my thing into Gemini and have it tell me what I did wrong. Since it was the one that summarized the paper in the first place. Alright, so we're getting fewer clouds now. That's at least good. But see, humidity is not fading off fast enough. So let's change the evaporation rate to really high. If it's a cloud and not evaporating. Okay, so evaporating only affects the clouds themselves. It does not affect activation. Humidity. Next humidity is completely whether we're not activating humidity and there's a spontaneous, so let's make precipitation smaller. Yes, if you were already humid, oh, we done run out of memory. We ran out of the RAM. My guess. Yeah, this is an expensive operation because we keep blowing that mesh away every time. Okay, Lex cubes blink. Alright. Step. Step. I mean, it's better. It's not completely overcast. It's not very clumpy though. And doesn't, yeah. Not impressed, yeah, so nothing is clumping. There's something wrong, I think. So the next thing to do would be to sort of simplify the code. Let me put it back the way it was. Step, wink, step, 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 step. Yeah, there must be a step we're missing. Even still, this is not very clumpy. Alright, let's let's simplify this code for the Tegoogles. So it can tell us what we're doing wrong. So we're gonna go through the things. Cells value. So we'll say here. We'll say. So we'll next val recombine cloud. No, next act. Next hum. next cloud. And then we'll say, oh yeah, new val. Okay, so first of all, we'll say we are trying to implement oh, there we go. Okay, so then we'll go back over here and new prompt. Trying to implement, but clouds either fill the sky with overcast or are too sparse, depending on the beginning parameters. And nothing ever particularly clumps into things that look like clouds. I think I might be missing something. Sorry, because you're treating the simulation logic as standard Boolean logic incorporating. Of course, you missing neighbor dynamics. The actual paper, how many neighbors are active? Ah. Yeah, I thought that was weird. We're just checking, is the neighbor active, but not like how many. Phase shifts. The paper does not typically run cloud formation, extinction, and vapor generation simultaneously in a single flat loop without constraints. The cellular automaton operates 3 distinct interconnected variables per cell. Activation phase transition represents the heat entry trigger. Aha. Available fuel. Cloud results. Your code handles next hum by resetting vapor based on chance every single frame, and the paper humidity is a finite resource that gets depleted when a cloud forms. It's only replenished slowly by ground evaporation. Aha. Why did it gotta change my parameters? To prevent clouds from just turning into perfect cubes of random noise, the paper applies directional probabilities. Yeah. Wind, basically. I haven't put wind in yet. Pairing is already covered by overlapping point sprites. Chosen from an atlas, from an image array, randomly chosen from an image array of cloud tufts. But your other stuff is good. Yep, I already know. It's perfect for this paper. Yep, that's right. The cloud form. Okay. All right. Well, you know what, guys? I actually have to really understand this. But I get what they're saying. Basically, if every time we're adding humidity, so basically humidity, and even though the old summary that Google Gemini gave me, it's wrong because it's treating everything binary. Also, each of these phases that it gave me, each of these phases is a separate pass. So potentially a separate pass. So there's basically I have to tweak it. Which maybe I'll read a little bit about it and play with it, and we can show it next week. And if there's anything left to do, but it's like already after 11, and I have to kind of drill in and actually understand what it's telling me, and that's going to be hard. But I get the like the root of the problem, which is what we're seeing here, is that each cloud is generated based on is there any neighbor, which is totally random. Rather than some, like in the game of life, the cellular automata, a classic example game of life, cells live or die based on the count of the neighbors. So by doing it this way, where I'm just checking whatever neighbor's active return true, which is essentially what it told me to do in the stuff, right? This is, where is it? Yeah, check 6-way neighbors for act. This is treating that as a boolean. Then that's limiting, right? So, and I want to argue with it a little. I want to figure out where the disconnect was with the original code it gave me. The reason is because in that conversation, we evolved this quite a bit to take on input from Mythruna terrain, like if we turn the town back on, like the fact that there are mountains and stuff can affect the cloud generation, right? And so, so I had a follow on conversation. So I need to figure out how to adapt that. So I'll do that offline. But I mean, it's looking kind of cool. And we could go back to this and we've got if we can get the clouds to form correctly, we've got a pretty good starting basis for some pretty cool stuff. Let's end the stream with a nice visualization. So let's go change the time. I think I have to change it other way. Where did the sun go? Which way did the sun go? There it is. We can't hardly see it because it's right behind this cloud, right? See, I can move over. So see, that's pretty cool. So if I get a position where we're sorting correctly, so that's pretty neat looking. And then if I come over here, all of these things are tweakable, right? In Mythruna's simulation, I can do it based on the time of day, so I can make it thicker or thinner, depending on what it is. And I can change. So the shadow color right now should be kind of a dark purplish orange, right? And the in fact, it's probably darker than that, to be honest, right? And then the light color, we can make that kind of a pinkish color. And maybe I like this over here, right? And then the sky color, we can make yeah, what do I want there? No, we want it even more gray, I think. Yeah, so you can get these kind of pretty, it could be a little too intense, to be honest. Anyway, you can get these cool looking, I think that looks really neat. Let's fly back over here to the town. So let's say you were standing on the parapets of this little tower looking over there as the sun goes down. Yeah, so I have some Z sorting issues to deal with. But yeah, this shows promise. So if I can get decent clouds to form that aren't just fractal clumps that evolve and change over time. Oh, the other thing is if you watch, oh, you probably can't see it. but these are changing over time. Like they animate. Yeah, probably YouTube's not going to let you see. But the shapes of the clouds themselves change over time. Like they animate over a 60-second period through all of the 16 different kinds of cloud images. That is a... Well, I thought I changed that to a settable parameter, but I guess I didn't. Anyway, so that's where we got. And thanks for joining, guys. Definitely like and comment. And if you haven't subscribed, please do so, because I'm really, really close to... I'm really, really close to 1,000 subscribers, which would be kind of cool. So that would be a nice milestone. Anyway, thanks for joining, guys, and I'll see you guys next week. Probably we'll wrap this up next week. And yeah, I hope you guys have a good, productive week if you're working on creative endeavors. And I will see you guys next time. Thanks a lot.